Hello, everyone, and welcome to today's webinar, How to Build Shared Disk SQL Server Clusters in Azure, brought to you by DH2i. Thank you to everyone for joining us. My name is Dana Rodriguez, and I will be your moderator. Today's session will be presented by DH2i Product Manager Connor Cox, and we're excited to have our guest presenter, Microsoft Program Manager Kevin Farley, join us as well. Before we hear from Connor Cox and our guest, Kevin Farley, I want to go over a few housekeeping items with you guys. All attendees will be muted throughout the entire presentation, but feel free to ask questions at any time using the Q&A pane on your screen. Connor and Kevin will answer as many questions as time permits at the end of the presentation. So with all of that taken care of, let's get started. I'll hand it off to your first presenter for today, Connor Cox.
All right, thanks Dana, and thanks everyone for joining. So I just want to set the stage a little bit here, and then we'll hear from Kevin and finally walk through a demo of some highly available SQL Server instances in Azure. So a lot of organizations are now really wanting to deploy their SQL Server workloads to the cloud for a variety of different reasons. But one of the things that oftentimes pops up is high availability. So high availability and disaster recovery oftentimes become a concern. And so on premises, what a lot of organizations are used to using to accomplish that and meet those goals and needs are failover clustered instances and SQL Server availability groups. So those are the really common approaches on premises to get highly available SQL Server. And so due to a kind of past lack of shared storage in the cloud, availability groups has been the prevailing approach. So availability groups, they're a really cool technology for a number of different reasons. You get things like readable secondaries, but there are a couple different aspects of availability groups that some people don't necessarily love, and it causes them to prefer instance level high availability with FCIs. So with AGs, you have a lot of manual configuration to do. Things like logins, jobs, alerts, etc. need to be managed manually. And then there are a lot of specific requirements for versions, additions, and then cost. So in order to do availability groups to a really meaningful extent, you need the Enterprise Edition of SQL Server. That can get kind of expensive depending upon how you're deploying. So really, as you can see here in the past, people wanting to do FCIs in the cloud have been limited in their ability to do so. But this has all changed with the recent introduction of Azure Shared Disks. So I want to hand it over to Microsoft's Kevin Farley to introduce this new Azure feature.
Thank you. So as Connor mentioned, within the Azure VM world, there was no way to have, well, the only way to have shared storage was to use file shares, which works for some things, but it is more moving pieces, not quite as performant as you might want. What we have just introduced is the Azure Shared Disk functionality, in which you can have a true shared disk that is directly attached to multiple servers and managed the same way that a shared disk, a physically shared disk, would on premise. So that's available now in some regions. So it's Ultra or Premium disks. Ultra disks are available in all regions at this point. Premium disks are currently West Central US, but that should spread out within the next few weeks to being global as well. So you have those different options as far as performance and cost options. So you have same LUNs attached to multiple Azure VMs. So it's just like the failover clusters that you're used to on premise. Works just like a SAN would. So at one node at a time can own the disk. The granularity for storage obviously is at the disk level. What you're failing over is an entire SQL instance going from node to node. So all of that is contained within that disk. So we're pretty excited about that. It was in preview for a while. It is now GA. So I encourage you to go out and try it. And Connor?
Yeah, thanks for that overview, Kevin. And so like Kevin was saying, you can get full instance level HA taking advantage of these shared disks. And one of the things that you need in order to make that happen is a clustering solution to control the access to the disk to ensure that it's only owned by the active node for a given instance for SQL Server instance level failover. And so that's what DxEnterprise provides. So DxEnterprise is a software technology from DH2i. It supports HA instances or FCIs as we're talking about. It also supports availability groups. So this is a clustering solution that also covers AGs, but for the purpose of this call, we're going to be focusing on that FCI use case. So what it does is automated fault detection and failover for SQL Server instances. So it's going to detect any fault, provide that HA if anything happens to the VM that the instance is running on, if there's any networking issues, and so on. So as I said, this takes advantage of shared and/or replicated storage for this particular use case, and it is a great complement to the Azure Shared Disk technology that's just recently gone GA. And it is fully supported with that technology. One thing that's very unique about DxEnterprise is that it supports both Windows and Linux. So this is in turn an alternative to other cluster managers such as Windows Server Failover Clustering and Pacemaker for Linux. But what it allows you to do is actually set up and create clusters on both of those platforms. So you end up with a single set of tooling and HA management experience for different types of workloads, or different platforms rather. So what I want to do is walk you through a demo of setting up a HA cluster for a SQL Server instance in Azure using Azure Shared Disks. So here's what we're going to do in the demo itself. We're going to just show you a 2-node DxEnterprise cluster in Azure. We're actually going to join a couple of nodes together. Now, one of the nodes happens to be running Red Hat Enterprise Linux, and the other is running Ubuntu. This is also very unique. Something that DH2i DxEnterprise brings to the table is that you can actually mix different flavors of Linux into the same cluster. So you've got that level of flexibility. What we'll then do is provision some storage once we have our cluster built. And so again, taking advantage of the Azure Shared Disks, they've been presented to both of these nodes. And so we'll manage those disks, format them, create volumes on them, and then create what's called a vhost. So I'll dig in a little bit deeper into what the vhost actually does and how that works. We'll then add a SQL Server instance to the vhost, and then show you the process of actually failing over the instance between two different nodes. All right. So, and then to wrap things up, I'm going to actually connect to a DxEnterprise cluster that's running on Windows to show you that unified management experience.
If I can jump in here for just a second. I would point out that although many of my customers will have clusters that are homogeneous, so all Red Hat, all Ubuntu, all Windows, what's really cool here is that you've got a single management tool set that is common across all of your different platforms. So if you have a Windows platform, you have a Ubuntu platform, the management tools is going to look the same. It's going to be common. You don't have to retrain and learn a new tool set going between platforms.
Absolutely, that's a great point, Kevin. All right, so I'm going to go ahead and jump over to my Azure environment. So I'm actually connected to a Windows Server node, Win3 within Azure, And I've got some SSH sessions connected to my Red Hat node and my Ubuntu node. So these are two Linux VMs in Azure. I've already installed DxEnterprise and activated it. It's actually the DxEnterprise offer on the Azure Marketplace. So you can go out there, you can pull down these images. They've got DxEnterprise installed, and then all you have to do is just configure your cluster from there. One thing I've also already done is presented a couple of Azure shared disks to both of these Linux nodes. So the first thing that we're going to do is join these nodes together, because right now they both have DxEnterprise, they've been activated, but they're separate, they're standalone. So we need to join them into the same cluster. So from this Red Hat node here, I'm going to just issue the command to set a passkey for the cluster. So DxCLI cluster set secret. Okay, so it's saying, are you sure you want to set a passkey here? We'll say yes. We'll enter our passkey, and that's now set. So we're going to go over to our Ubuntu node on the left-hand side and go to DxCLI join cluster. So it's saying, are you sure you want to join a cluster? If it's already a member of a different cluster, it'll be kicked out of that cluster. We'll say yes. We are not going to join it over NAT since these are already in the same network. And the target server here is going to be our Red Hat node. Market rel 2. So now we're prompted for the passkey that we just set. So we'll enter that in here. And we should have this node then join to the other cluster, so the other node, the rel2 node. So that's completed. So from here on out, what I'm going to do is actually launch the DxAdmin management UI from my Windows node here. So that's going to allow me to set up my cluster using a UI. That is not required. You can absolutely continue to set up your cluster from the command line. That's what a lot of our customers do on Linux, but just for the purposes of the demo, I'm going to pull up DxAdmin so that we can see things a little bit prettier here. So we're going to connect to our Red Hat node, enter our passkey, and connect. So here from the tree view on the left-hand side, I can see both of my nodes, rel2 and Ubuntu 2. So I can see all sorts of information about them, the operating system they're running, some performance statistics about the nodes themselves and so forth, but they're joined together into a cluster. So before we can add our SQL Server instance, we need to manage the disks that I've presented, so the Azure shared disks that I've presented to both of these nodes. So DxEnterprise actually has its own storage manager here that we can use. So what I'm going to do is manage this disk. So I'm going to right click and say manage and select the checkbox next to the disk that I want to manage. And you can see here where the disks have been presented already. So I've got these two 5 gig Azure shared disks that I've presented to both of these nodes. So I'm just going to manage one of them. So that means just put it under DxEnterprise management and go ahead and put it online on the Red Hat node. So we'll say yes. And then at this point, we're just going through the process of creating a volume on this disk. So you can specify how much of the disk you want to provision into this volume. So we'll just create a volume using the entire disk. And then I need to format it. So you have some more options here. You can set a label for this particular volume, select your file system and the block size that you want to use here. So I'm just going to leave those all as default. Click OK. So now we've got a volume created. Once this completes, we'll have a volume created on this disk. And then the last step is we're going to then create a mount point for this volume, so the endpoint that we will set to access this particular volume. Just give that a few more seconds, and now that's completed. And now I'm going to hit set logical drive, where I can then add a mount point. Okay, so I'm just going to enter a path here of volume 1, submit that. Okay, so now we've provisioned this volume and associated a mount point to it. So that's completed. The next thing we're going to do here is add a vhost or virtual host. So the vhost is an IP address and name pair. This is what is going to become your connection endpoint. So we're going to associate our disk and our SQL Server instance to this vhost. And then you'll be able to then connect to the SQL Server instance via the vhost name or vhost IP address. So with that, I've got vhost 1 that I'm going to set up here. You will want to set up some means of resolving this name and IP address pair. So typically that means entering these in DNS so that it can be resolved. But in this case, I've got an IP assigned to it, 10.1.4.10. And then we're saying which nodes do we want this vhost to be able to be active on. So bringing over both of the nodes, and then what's the failover ordering? So we're saying here, first start this vhost up and any associated applications on the Red Hat node, and then it would fail over down onto the Ubuntu node. And if I had more nodes, I could add them as well, but I've just got a 2-node cluster here. Click OK. So we've got a vhost. And so you can see here that we've got the 10.1.4.10 IP address associated with the vhost. It's active on the rel2 node. And so if I click on the rel2 node, I can see that the IP address is bound there. So when we move the vhost, let's say, for example, we just want to start it up on the Ubuntu node, it's going to rebind that IP address onto the Ubuntu node. Right, so that's what gets us our consistent endpoint. So I'm going to start it back on rel2. Right, so now that we've got our vhost, I'm going to associate that volume with the vhost. So what does this mean? This means anywhere the vhost is active, we will control the access to the disk and make it only available to the active node for the vhost. Okay, so right now, I'm going to just select this disk that we provisioned prior, click submit. So right now, this volume, this disk, is read-writable only to the rel2 node. And then when it fails over to the other node, it would obviously be only available to that node. We use SCSI3 persistent reservations to set that ownership to ensure that the data is integrity is preserved. All right, so we've got our vhost, we've got our disk. Next step here, we're going to add our SQL Server instance. So before doing this step, you'll want to install a SQL Server instance on any of the nodes that you want to participate in the vhost. So I have already gone out and done that prior to this demonstration. So we've got our default instance here because it's Linux. That's the only option that we have. So MS SQL Server, we can add a description for the instance if we'd like, and then the port for SQL Server connections. And then at this point, we need to set the path for the data and the logs associated with this instance. So we want that to live on the shared disk. So we'll go ahead and select those. The next part here is we need to enter a SQL Server login that has a sysadmin role to carry out this add instance process. So in this case, I'm going to be using the SA credentials, the SA login, but you can always create a different login as long as it has that sysadmin role, because we need those different grants to carry out this process. So go ahead and enter my password, click OK, hit yes. So this process is started. From here, you can always click on this little gear under process, and it'll show you all of the actions that you've taken within the tool. So if I click here, I can see that that's processing right now. So what's happening right now? So basically, the tool is making a copy of the data and the logs from the local path on the Red Hat node and copying all the data, the user databases and logs, to the cluster disk. The other thing we're doing is we're making this instance now believe that its server name is the vhost name rather than the underlying VM name. So again, if you were to query this instance and do a select add at server name, it would return with vhost1. So that's what gives us our consistent connection string. So that process is done. I can click on the instance. I can see various information about it. But at this point, this instance is now highly available. So if anything happens to the instance or the VM that the instance is running on, it will automatically fail over from the Red Hat node onto the Ubuntu node. You can also do manual failover, of course. So if we wanted to, say, make this instance now active on the Ubuntu node, we can do that by right-clicking on Ubuntu 2 and say Start Hosting on Node. So that kicks off the failover. What that does is it stops the instance on the Red Hat node, changes the ownership of the disk to be owned by the Ubuntu node, rebinds that IP address of vhost1 onto Ubuntu 2, and starts our default instance on Ubuntu 2, and that process is completed. Okay, so stopping the instance, starting it up, changing the ownership of the disk, and rebinding the IP. So that is a cluster on Linux. As Kevin mentioned, we can also do this on Windows. So what I want to do is just cut over to another cluster that I have out there that it consists of a number of Windows Server VMs. So this one, demo 1 through 4, got some Windows Server nodes here, 2016 and 2019. And if I go to DX cluster, I can actually get a cluster view of this environment. So you can see here I've got about a dozen SQL Server instances. I can see the different versions of SQL Server that they're running, the virtual hosts that they're associated with, the TCP port, and then the node that they're active on. So for example, accounting is active on demo 3 right now. And the numbering indicates the failover ordering. So if this demo 3 were to fail, it would, I guess in this case, go back to demo 2. But for customer 1, active on demo 1, if that were to fail, it would fail over onto demo 2, and so forth. So as you can see, we've got the same clustering tech for both Linux and Windows. What this demo didn't go into is availability groups, but you can also add an availability group and make an availability group highly available between nodes. Okay, so very flexible technology here, agnostic to any sort of infrastructure or platform. And now, because of the Azure Shared Disk features, we can run these shared disk clusters in the cloud. So before we get into questions, I just want to point out a couple of resources here for you. The DxEnterprise offer on the Azure Marketplace, you can go out and they are VMs that have the software pre-installed on them. So I encourage you to check that out. We've got some quick start guides available that walk you through exactly how to set this up. We've got an option to get a free trial or a demo. If you'd like to see a deeper demo, you can check out that URL. And then there's a link down here for more information about Azure Shared Disks. If you want to check those out in a little bit more detail, you can visit that URL as well. All right, so with that, let's go ahead and take a look at some of these questions that have come in. So again, feel free to type in any questions that you have, and we will get some of those answered for you. All right, so this is a question, it looks like for Kevin. So Kevin, is there a limit on the number of nodes that you can present a Azure Shared Disk to?
Sorry, I had to unmute. I'm sure there is, but it's fairly high, probably more than you would want to manage in a cluster. So I'm guessing 64, but I'd have to look it up.
Gotcha. All right. Someone wants to know, how is DxEnterprise licensed? So DxEnterprise is licensed on a subscription basis. So we just look at per server per year. And then we also have with some of our cloud offerings, you can get an hourly rate there. So spin it up, spin it down, and just pay for your usage there. But it's based on the number of servers that you're running. All right. Somebody wants to know, is there a limit to the number of platforms you can connect? So no, so DxEnterprise, I believe that's a question for me, but we don't have a limit there. The OSs that we support are Windows Server, Red Hat, and Red Hat derivatives, as well as Ubuntu. So if you have basically any node that's running one of those supported OSs, you can absolutely use DxEnterprise for it. So Kevin, is there an uptime SLA associated with the disks themselves?
There is, as with all Azure offerings. I was just looking to see if I can find it. I'll get back to you when I find it.
Sounds good. In the meantime, someone wants to know, what is the process to upgrade DxEnterprise? So DxEnterprise actually has the ability to do what's called freeze a node. So if you freeze a node, that says turn off HA for the particular node. So nothing would fail over, off, or onto that node if any thresholds were met or exceeded. At that point, you can actually uninstall DxEnterprise, reinstall the newer version, and you can do so without ever having to take any outage or downtime to do the upgrade itself. You can do it all hot during production hours. So we have a lot of customers that take advantage of that capability.
So for uptime, there's a number of configuration options. So you can choose to have the disk hosted in multiple availability zones, which brings your uptime higher. So it's going to be in the range of 99.9% and 99.99% uptime.
Excellent. And so, Kevin, somebody else wants to know, are there any options for increasing or decreasing the size of an Azure Shared Disk?
I'm going to say probably not. Again, let me look it up.
Cool. Let's see. Someone wants to know, do you have to use a specific version of SQL Server with DxEnterprise? So we support what Microsoft supports. So you can essentially look and see what versions that they support, and those same versions are supported with DxEnterprise. Looks like we might have time for one more here. So someone says, what happens to the data when failing over a managed instance between hosts? So the user data stays in the same location. We just change the ownership of who owns that particular disk. So the data doesn't actually move. It just stays in that shared location. All right. So Kevin, do you want to follow up after the session with the answer to that increase, decrease size question?
Yeah.
It's like we're getting a little close on time. All right. So with that, want to hand it back to Dana to wrap things up here.
Thanks, Connor. And thank you to everyone for joining us. That is all the time we have for today. If you have any additional questions, feel free to connect with us. If we didn't get to your question, we will reach out to you personally to answer that. We will also be following up with you shortly with the recording of this webinar, and there will be a short survey after the webinar as well that we would appreciate you filling out. Thank you again for your participation, and we hope to see you at our other upcoming webinars. Have a great one.